Okay, so Pythagoras' theorem, it can be explained quite visually if you look at the picture. When you've got any right angle triangle, then the two smaller squares, as you can see the green and the purple, will combine to give you the larger square, which is the red one. So the areas visually will go together to create the larger area. Now, this is called Pythagoras' theorem. In the picture you can see it as the square of A plus the square of B is the square of C, and that is the formula that Pythagoras is well known for. Now, the C part, as it says, is always the longest side of the triangle, and in particular it's always found directly opposite the right angle. A and B, doesn't matter which way around you label it really, is just because they are both the two shorter sides. Now you should have covered this in lesson, so it's just a reminder. And remember, a posh way to call the longest side is the hypotenuse. So it only works for right angle triangles. The square of the hypotenuse is equal to the sum of the other two sides. Now I'm going to talk you through an example. For example, you wanted to find out one of the missing lengths in a right angle triangle. If the lengths were given 3 centimetres by 4 centimetres and you had to find the missing length, and that could just be a symbol x, you're looking for the length, you could use Pythagoras' theorem. So you can either visually imagine it or put the pictures on. It's the length, which is 3, that needs to be squared, plus the length of 4, which needs to be squared, so plus 4 squared, to give you the x squared. So 3 squared, just make a bit of space, 3 squared is 9, 4 squared is 16, and if you add those together you make 25. Now that's the area of the big square. So the big square is 25 centimetres squared. Now you can either think to yourself, oh, what number times is by itself to make 25, or based on the inverse operation of squaring something, the inverse is to square root. So 25 square rooted gives you the length of 5, because 5 times 5 gives you 25. Now that was one of the easier examples, because you've got the two shorter sides given. And again, that could have just been done purely by the formula a squared plus b squared equals c squared. You had 3 squared plus 4 squared. That got you the 9 and the 16 that we just said, which was 25 is equal to c squared, and then balance method, inverse, square root, and that gets you still c is 5. Okay, so the other star question is that you could be given the longest side and then you need to work out what the missing length is. And again, it would have to be a perfect right angle. If, for example, you were told that the longest side is, let's say, 12 centimetres and one of the shorter sides is 4 centimetres. You could still approach it visually and just think, well, what are the two areas that we know? You know this area and then you know the bigger area. So if you were doing it visually, you could work out the area of the 12 centimetre square. So 12 squared is 144. And you could work out the smaller one by doing 4 squared to get you 16. Now, if you didn't remember the formula, then you could actually use this method just for the visual, because you know that the two smaller ones, so this one and then this one, combine to give you the larger one. So let's write that out. 16 plus something gives you 144. You could then use inverse operation to work out what the question mark is to get you the area. It would be 144 minus that 16. That would give you 128, so the question mark is 128, and that is the area of one of the second smaller squares. So we can just double check it. 16 plus 128 makes 144, but that isn't the final answer because that is the area. So that is the area of that shape there. Remember, that is an area, so if we want an inverse operation, square root the 128, and that will give you what the missing length of that square is. So if you square root 128, you get 11.3 to 1 decimal place, and that will be centimetres, and that will be your final answer for that one. Now again, that could have been done through the formula. If you are good with formulas, so a squared plus b squared equals c squared, you could then just pick a to be the length that you knew from the question, and if you just quickly have a look, it was 4 centimetres. So a was 4 and we squared it. We didn't know what b was, so we can just leave it as that, and then we knew that c was 12. So you could use the formula just in the same way, 4 squared 16, leave b squared, and then work out the 144. You can then subtract the 16 from both sides to work out the b squared part, and that will give you the 128 again. And then your final stage on the balancing to square root both sides to get the b as what we just found, which was 11.3 to 1 decimal place. So if you prefer the formula, you can do it that way. And I'm fully aware that some people wouldn't even use that formula in the first place. They may have just rearranged it in the start to do c squared minus a squared is b squared. So there's lots of ways you can do that depending on your preference.